In this video, we will see the derivation of the electric field due to infinite sheet charge in 4 different methods. Okay, so the first method is nothing but we will take the infinite sheet charge on the xy plane, and we will find the electric field at the observation point, which is on the z-axis. So we'll assume the x-axis is coming out of the screen, and the screen is nothing but yz plane. So I am taking the infinite sheet on the xy plane. So it is not finite sheet, it is infinite sheet. It is extended towards minus x-axis, plus x-axis, minus y-axis, and plus y-axis up to infinities. Okay, minus infinity to plus infinity, minus infinity to plus infinity along the x and y-axis respectively. And this particular sheet is having the sheet charge density or the surface charge density ρs, which is uniform. That means not changing with respect to spatial coordinates. And we'll consider the source point on this particular sheet charge is given by rho comma phi comma 0, because the point is available on the xy plane, z coordinate is 0, and in the cylindrical coordinates that x comma y can be represented with the rho comma phi. So we are going to solve this in the cylindrical coordinate system, and the observation point I am taking on the z-axis, positive z-axis, and which is given according to this source point. The source point SP is given by rho phi 0. With respect to this rho phi 0, the observation point OP, the coordinates are given by, because it is there on the z-axis, rho value is 0. With respect to this source point, the phi coordinate will be phi only, because here phi is there in the source point. The observation point also should have the same phi value. Okay, we are working in the cylindrical coordinate system. Whatever the phi coordinate value is there in the source point, same phi coordinate we have to take in the observation point, because from that particular observation point to see the source point, it is to be with the same angle phi. Then we'll assume that the observation point is at the height of z from the xy plane. Okay, so source point is ready, rho phi 0, observation point is ready, that is 0 comma phi comma z. Then we need to find the electric field at the observation point due to this particular infinite sheet. So this is the establishment of the problem. Now how to solve, we will see. So I will calculate, or I will draw the r bar which is joining the source point and the observation point r bar. So r bar is given by OP minus SP, that is equal to 0 comma phi comma z minus rho comma phi comma 0. It is equal to minus rho cap plus z into z cap. So what is the magnitude of r? It is equal to square root of rho square plus z square. Then according to Coulomb's law, due to this particular small differential charge dq is available at the source point. So dq is equal to, since we are working with the sheet charge, rho s into ds we can write. As we are working in the cylindrical coordinate system and that small differential surface is available on the xy plane, that is created because of the product of the two differential lengths. One is due to rho, second one is due to phi. So d rho is the differential length due to the changes in rho, and rho d phi is the differential length due to the changes in phi. The product of these two will give the ds. So finally we can write rho s into rho d phi is nothing but dq. Now from the Coulomb's law, the differential electric field due to that particular differential charge dq is given by dq by 4 pi epsilon magnitude of r cube into r bar. It is from the Coulomb's law. So it is equal to dq is nothing but rho s into ds, and ds is rho d phi by 4 pi epsilon, and r bar is nothing but what did we get, OP minus SP. That means we'll get minus rho cap and then plus z into z cap. This is the r bar by a magnitude of r cube is there. So that is rho square plus z square power 3 by 2. Okay, we got like this. Okay, then we have to do integration here with respect to rho and phi to get the complete electric field. So E bar is equal to rho s is constant, 4 pi epsilon is constant. Then we have to do the integration here. But before doing the integration, one more point is, this is the electric field we got. Okay, only due to, because this is the sheet we can take. Now, if this is the differential charge dq and this is the OP, because of this particular charge, you will get the electric field is like this. That is why you have the two components, rho component and z component. But the counterpart of this particular charge, you can have here another charge also, because it is extended in the infinite duration, that is symmetrical. And because of this particular dq at the another side, we'll get the electric field in this particular direction. Okay, because due to the point charge, the electric field is along the line which is joining the OP and SP. But the resultant direction will be in this direction. That means in the resultant direction, it will be in the Z component only. So you can able to remove this rho component here. Okay, so now what we will get, rho s by 4 pi epsilon is constant as I said, and we need to perform the integrations with respect to rho and phi. So Z is also constant. So Z into Z cap I'm writing here. Then I have to do the integration with respect to rho. So rho d rho by rho square plus z square power 3 by 2. Then d phi is also there. So integration of d phi, where phi changes from 0 to 2 pi. And here integration with respect to rho, that is from 0 to infinity. If you take 0 to infinity, then only that is for the infinite sheet charge. Okay. So it is equal to, what can I write here? In order to solve these integrations, here I will consider rho square plus z square is equal to another variable t square. Okay. So then we need rho d rho. So perform the differentiation here. Here z is constant. Remember that one. So 2 rho d rho is equal to 2t dt. Okay. So rho d rho is equal to t dt. You can write. Then lower limit calculation. If you take rho is equal to 0, t is equal to z, you will get. And upper limit calculation, if you take t is equal to, sorry, rho is equal to infinity, t is also infinity. Okay. Then we'll do the integration for that one. Rho s by 4 pi epsilon. Okay. Z into z cap. Integral. I'm changing the rho variable with respect to t variable. And lower limit I got z, upper limit I got infinity. Rho d rho means I can write t dt by, here what I will get here, rho square plus z square is t square. Power 3 by 2 is there, that means t cube I will get. Okay. Then integration of 1 with respect to phi is phi with the limits 0 to 2 pi. Okay. Then it is equal to rho s by 4 pi epsilon z into z cap. Here 1 by t square is there. So integration will be minus 1 by t. And limits also have to substitute. So 1 by t means 1 by infinity is the upper limit substitution. 1 by z is the lower limit substitution. And if you substitute the limits here 0 and 2 pi, for phi you will get here 2 pi minus 0. So it is equal to 1 by infinity is 0, minus into minus of 1 by z is 1 by z. So that z and this z will be cancelled. Okay. Then what I will get here, 2 pi is there. So 2 pi into 2 is 4 pi. So rho s by 2 epsilon into z cap. So finally I got E bar is equal to rho s by 2 epsilon into z cap. So this is what I got. Once if you remember the diagram, we have taken this infinite sheet on the xy plane. Okay. And the observation point is on the z axis. Here OP is there. Okay. So because of this particular sheet, we got here electric field is rho s by 2 epsilon into z cap. This is the electric field. Instead of taking the observation point on the positive z axis, if you take on negative z axis. Okay, what will you get means here, if it is the OP, rho s by 2 epsilon into minus z cap you will get. Okay, so what is the general expression to give means rho s by 2 epsilon into n cap. That means sheet is xy plane, but a resultant electric field is having the direction of the z cap or minus z cap. That means it is having normal to the sheet. The electric field is normal to the sheet. That's why I can take here n cap. So if the sheet is zx plane, then the direction will be in the y cap or minus y cap. Okay. If the sheet is yz plane, then the direction will be x cap or minus x cap. That's why here we have to take n cap. So this is the way of finding the electric field due to the infinite sheet. It is just method 1. So in the method 1, how we are defining the method 1 means the infinite sheet directly we have taken on the xy plane, and using the Coulomb's law approach we have done this particular derivation. Now we will see method 2. So method 2 approach is same, but instead of finding the electric field due for the infinite sheet, we will find the circular ring of finite radius r. So here circular disk we have to take, not circular ring. Circular disk of finite radius capital R. Then R is tending to infinity, then it will become infinite sheet. So our aim is to get electric field for the infinite sheet only. Okay, so instead of finding the electric field directly for the infinite sheet, in the method 2 what we are doing is first we will find the electric field for the circular disk of finite radius. Then we can make that radius is tending to infinity. So whatever the electric field we will get by making R is tending to infinity, we will get as the electric field only. Okay, for the infinite sheet. So that is the approach we are making. So we'll assume that the sheet is available on the xy plane like this. So it is x-axis, it is y-axis, it is z-axis. You can see OP is on the z-axis, having the coordinates 0, 5, z, and SP is on the xy plane. Okay, that means on the circular ring, having dq is equal to rho s into ds. It is equal rho s into ds is rho d rho d phi. Okay, and it what is the SP? SP is given by rho 5, 0. Okay, then we will take the electric field due to this source point. You may have here another source point, and its electric field is in this particular direction. If this is the OP, the resultant direction is in the z direction only. Okay, here also same rules, nothing is there. So first I will write r bar. This is our r bar actually. R bar is equal to OP minus SP. That means 0, 5, z minus rho, 5, 0. So it is equal to minus rho cap plus z into z cap. Magnitude of r is rho square plus z square power 1 by 2. Okay. Then according to Coulomb's law, we can write dE bar is equal to dq by 4 pi epsilon into magnitude of r cube into r bar, and dq is nothing but rho s into rho d phi by 4 pi epsilon, and r bar means minus rho cap plus z into z cap by rho square plus z square power 3 by 2. So as we know, due to all the charges are opposite charge, the resultant field will be in the direction of the plus rho cap plus z cap. So this will be cancelled. Okay, so resultant field will be in the direction of the z cap only. So this can be removed. So now if you perform the integration, then electric field is equal to, you will get rho s is constant by 4 pi epsilon is constant. Then integration with respect to rho, from where to where we have to do here, not from 0 to infinity. If you perform from 0 to infinity, you are doing the integration for the infinite sheet. You are finding for infinite sheet. But here we are taking the circular ring of radius r, so that radius should be from 0 to r, 0 to capital R. Okay. Then rho d rho by rho square plus z square power 3 by 2, and second integral where phi changes from 0 to 2 pi d phi. Okay, so to solve this one, again I am taking rho square plus z square is equal to t square. So 2 rho d rho is equal to 2t dt. Lower limit is when you take rho is equal to 0, t is equal to z. Upper limit when you take rho is equal to r, t is equal to square root of r square plus z square. This is upper limit. Now we can proceed for the change of the variable. So E bar is equal to rho s by 4 pi epsilon integral t is equal to z2 root of r square plus z square. Rho d rho means I can write t dt by, what is this one? T square. Power 1 by 2 means t cube. You will get same integration, and here you will get a integration of 1 with respect to phi is phi, and limits are 2 pi minus 0 is 2 pi. So it is equal to rho s by 2 epsilon, and here 1 by t cube is there, 1 by t square, and here we will get 1 by t minus 1 by t will get. Okay. Then the limits will be, here lower limit is z, upper limit is r square plus z square. So it is equal to rho s by 2 epsilon. Here we forgot z cap, z cap, z cap, z cap, z into z cap, z cap. Okay, the minus is there, and upper limit substitution is 1 by root of r square plus z square minus 1 by z. So it is equal to rho s by 2 epsilon z into z cap 1 by z minus 1 by square root of r square plus z square. So this is our electric field due to circular ring of radius capital R. As I said earlier, when R is becoming infinity, circular disk will become infinite sheet. Okay. So in this particular expression, if I take the infinite sheet, what I should get? Electric field rho s by 2 epsilon into z cap I should get, or n cap I should get. So in the circular disk, we have to make R is tending to infinity. So if you make that one, R is tending to infinity means that this part will go, if you take R is infinity, it will go 0. So only here 1 by z is z will be cancelled. So electric field is equal to, we can get rho s by 2 epsilon into z cap. Okay. So when you take by making R is tending to infinity, we got this one. Okay, this is the second method. Now we will see third method. It is different from previous two methods. So what is the approach we are following is, we will use, instead of using the point charge concept, we will take the line charge concept. We know that due to the infinite line charge, electric field is given by rho L by 2 pi rho epsilon into rho cap. Okay, so using this one, we can able to get the electric field for the infinite sheet. Previously, using E bar is equal to Q by 4 pi epsilon into R square into R cap, we have done the derivations. E bar was calculated. But now instead of using this one, we are going to use this one. Okay, that means instead of dividing the entire sheet into points, now we have to divide the entire sheet into lines. So we'll take, this is a YZ plane, any plane you can take. This is x-axis coming out of this plane, and infinite sheet I'm taking like this. Okay, so in the infinite sheet, this can be considered like I'm taking again. This infinite sheet will take as the vertical strips. Okay, so if you take this particular strip particularly, to get the entire sheet, what we need to do? We have to do the integration with respect to y-axis. Okay, so this is having the line charge density rho L, or we can take d rho L. This d rho L is to be written in terms of the sheet charge density rho S. It is having sheet charge density rho S. Previously, dq is equal to, how we have written, rho S into ds. Okay, now we have to write d rho L is equal to rho S into dL only. Okay, so coulombs per meter is equal to coulombs per meter square into meter. Coulombs per meter, it is coulombs per meter square into meter. So what is the dL? So d rho L is equal to rho S into, the dl is changing with respect to y-axis. That is why you have to take here dy. Okay. If you assume that this line is available at y dash, you can take here y dash. So that strip is this one. Along the z-axis, it is infinite length. Okay. Along the z-axis, it is infinite length only. But it is available at y dash from the origin. Okay. So by keeping all these things, we can able to do the rest of the part. So d bar is equal to d rho L by 2 pi rho epsilon into rho cap. Now what is that rho? Perpendicular distance. Okay. And what is the rho cap? Limit vector in the direction towards the observation point. So this is your observation point. We are solving here with respect to Cartesian coordinate system x comma 0 comma 0. So from the line, if you take the rho bar, okay, so it is equal to d rho L by 2 pi epsilon. If you take here rho bar, here we will get rho square. So what is that rho? Here the source point is given by 0 comma y dash comma 0. It is a source point. Okay, then r bar is equal to OP minus SP. It is equal to x into x cap minus y dash into y cap. Okay, then just make the substitutions here. So d bar is equal to d rho L means what we can write, rho S into dy dash. Okay, then what is the rho bar? Rho bar or r bar, whatever it may be, it is equal to x into x cap minus y dash into y cap by 2 pi epsilon into x square plus y dash square. Okay, then now similarly, because it is symmetrically distributed, the resultant direction will be in the perpendicular to the sheet. So perpendicular distributed means a positive x direction here, because observation point we have taken on the positive x axis. So result will be in the x direction only. So we can remove this particular y component. So now we have to do the integration. E bar is equal to rho S is constant, x is constant, x cap is constant by 2 pi epsilon. So we have to perform the integration with respect to y, and y limits or y dash limits are from minus infinity to plus infinity dy dash by x square plus y dash square. Like this we got. Okay, variable is y dash, not x. That's why x cap we have written outside. Okay, along the y-axis, all the strips are available. So if you perform the integration, you are going to get the electric field due to the total infinite sheet, where the variable is the y dash. So it is equal to rho S into x cap by 2 pi epsilon. Here, because x is the constant, y is the variable, the integration will be 1 by x into tan inverse of y dash by x. And limits are from minus infinity to plus infinity. So here this x and this x will be cancelled. Rho S into x cap by 2 pi epsilon. Then what did we get here? Tan inverse of infinity is pi by 2 minus tan inverse of minus infinity is minus pi by 2. So what we will get? This is pi, this is also pi. So we got rho S into x cap by 2 epsilon. So rho s by 2 epsilon into x cap is perpendicular to sheet. That's why I can take n cap. So in this method also we have solved the electric field due to infinite sheet. So now another method, that is method 4. Now also we are going to get electric field due to the infinite sheet due to the method called Gauss law. So to apply the Gauss law, we have to choose one imaginary Gaussian surface, and we have to choose that one in such a way that the electric flux is either perpendicular to the Gaussian surface or parallel to the Gaussian surface. Okay, so what is the Gauss law? Closed surface integral of d bar dot ds bar is equal to q enclosed. Okay, so we'll take the sheet is like this. So we'll assume here the cylinder is the Gaussian surface. Okay, I will assume this cross-sectional area is S. So because it is having plus rho S, it will give the radiation away from the sheet. Okay, so this area is S, this area is S, this area is also S. So what is the amount of charge available in that particular area? Charge enclosed is equal to, from the rho S, if you want to tell, that is rho S into S. Coulombs per meter square into meter square is equal to coulombs. So we have the right side part. So in the left side part, closed surface integral of d bar dot ds bar is equal to q enclosed, that is equal to rho S into S. This closed surface integral we have to perform 3 times: top, bottom, and curve is equal to rho S into S. So without thinking much, we can take this curved surface integral is equal to 0, because no flux is passing in curved surface. Okay, so what we can take here, integral top surface. Top surface is created because z is equal to some constant. Okay, so otherwise here we can write d bar is nothing but dz into z cap dot, this is ds into z cap, plus bottom. So this is top, this is bottom. Here dz is available in the negative z direction. Okay, and what is the surface direction? Surface direction is also the negative direction. Anyhow, curved surface integral is 0. Okay, then it is equal to rho S into S. Then what did we get? dz into S plus dz into S is equal to rho S into S. Then 2 into dz into S is equal to rho S into S. So dz is equal to rho S by 2. Epsilon into Ez is equal to rho S by 2. Ez is equal to rho S by 2 epsilon. V bar is equal to Ez into Z cap, that is equal to rho S by 2 epsilon into Z cap. So very general thing is E bar is equal to rho S by 2 epsilon into N cap. Okay, what are the conclusions? We have done this one in 4 different ways. Method 1, method 2, Method 3, method 4. Coulomb's law approach. Coulomb's law approach. Here, point charge electric field is used. Here, circular disc. R is tending to infinity. Then here, again Coulomb's law, but line charge concept is used. Next, method 4, it is Gauss approach. So in 4 different ways, we can able to solve this particular electric field due to the infinite sheet. Thank you.